So at first, referring to to the speaker before, I would like to ask you: are you German speaking or English speaking? English. Okay, fine. Okay. Yes, thank you for coming and for your interest. I would like to give you an insight in a new class of materials called foam, and it's used in technical insulation. Reduction of CO2 emissions by using plastics. At first glance, it sounds a little bit strange and doesn't match, but at least this is exactly what we are commissioning, what we want to do, and what we have committed ourselves to do. Because we have small structures, and with these structures, we want to achieve the grade. Using small forces to achieve the grade, that is what we have as our motto. And these are not only empty words, this is our mission, this is our vision, and that's what we manifested here. We want to redefine the value of plastics with establishing a new class of materials. Now, what is foam and what does it make so special? Foam is a nanoporous foam with a nanostructure or pore structure of less than 50 nanometers. Compared to a common foam, it is more than 2,000 times smaller in the pore structure. And as you can see at the pictures, you have the same magnification on top of foam and below of a common foam. And just to make it visible to the human eye, we had to increase the magnification by factor 50,000, as you can see in the middle here of the picture. But the reason why we have to reduce the pore size is to reach a better insulation value. And this is due to the fact that by reducing to the nanometer range, the cell gas molecules interact more with the webs between the pores than with other cell gas molecules. And that makes a directive or direct transfer of the heat not possible anymore. At least the transfer via cell gas is the most important and the main factor for the efficiency of the thermal conductivity. To reach the small pore structures, we cannot use any polymer. So that's the reason why we have to polymerize the materials ourselves. We buy monomers, we need some additives to change the structure and to reach the effect that at least we can have a nanoporous foam. We are based at the moment, or our basic material is a PMMA or MMA that we modify. But at least we can do it also with other materials in the polymer range. This we foam in the second step, and at least then we customize the material by grinding or by at least by molding panels from it. Here you can see the different fractions we have at the moment. Beginning with the granules, that is what we have from the extraction. We have two standards, smaller 5 millimeters and smaller 10 millimeters. Then we grind it down to the particle sizes of the flakes, smaller 2.5 millimeters and smaller 1 millimeters, or at least down to a fine powder of smaller 300 millimeters or smaller 50 micrometers. At least all the particle size between we can produce as well. We can sieve the material and we can do it depending on the customer's need. Last but not least, our panels, a very new product. In the next step, I will go a little bit deeper in it. Here, coming back to our sustainable impact, what I was mentioning at the beginning, we divided into two parts, the production impacts and the application impacts. And our production is energy saving, it's an energy saving technology, and we have additionally circular processes with a blowing agent. Application impacts are the high efficiency in insulation and additionally a very low carbon footprint. This is the reason why we have been funded several times by several organizations and also have the Solar Impulse label. Here you can see a little bit about the facts of some foam. It's a foamed acrylic copolymer. Granules, flakes, powder, I said before. Pore structure is open cellular and very homogeneous. The pores, yes, we say it's here below 50 nanometers. At least the peak is around 20 to 30 nanometers. It's absolutely hydrophobic, so water cannot come in, but in gas form it can go through. And we use it in a temperature range between deep minus degrees and plus 80 degrees. In a nutshell, some foam is climate friendly, high performance insulation, versatile and flexible in application, and excellent in the price performance ratio. Okay. Coming back to the panels, we have reached, it's not so long ago, that we have a lambda value in the panels of less than 20 milliwatt per meter in Kelvin. So it is very efficiency by outstanding insulation performance. It is lightweight. We have a weight between 150 and 200 kilogram per cubic meter. And it's depending a little bit on the stability and compressive strength needed. And it has also an excellent price ratio performance. Compared to other high performance materials, we have around about half of the pricing. Okay, here you can see on the right side on top a comparison of different foams. On the y-axis, you can see the thermal conductivity. On the x-axis, there's a compressive strength with 10% compression. And you can see this is some foam with a little bit below 20 in lambda. The compressive strength keeps. And this is, for example, an EPS, an XPS, and so on. Yeah, the fields of application are, for instance, insulation for transport vehicles of cold chain logistics and also maintaining the temperatures in refrigerated or heated vessels. Another thing is the pour-in insulation, blow-in insulation, depending on if you need pressure or if you can have a loose filling. The material reaches a lambda value of below 25. We use it for cavities, insulation of big cavity tanks, for example. It spreads even in the smallest areas of the cavities and is flexible to process. The fields of application are, for example, liquid gas tanks for storage and transport, thermal containers or thermal flasks, and cooling and freezing units. Also, a very new development of us is the SumFoam paste. The Samform paste is a mixture of powder and binding agent, and you can flexible use it for coating, for filling. It is highly insulative as well. We have here mentioned below 30 in the lambda value. But we are currently in the improvement. We are sure to achieve a lambda value of below 25 as well, since it is nearly only our Samform material on the paste. Flexible for different shapes. Yeah, you can use it at roundings and wherever needed, and it's also easy to apply. Yeah, here's some fields of application. Insulation of round bodies such as pipes, closure of insulation joints, and repair of insulation gaps. Yeah, so if you have it was too fast. If you have here, for example, a gap or something breaks from a panel, you can add this paste and you can close the gap. A completely different use of Samform is the kind of microencapsulation. If you don't use the structure of the nanopores, you can absorb with the foam oleophile substances, like, for example, phase change materials. And so you have no insulation anymore from the pores, but the phase change materials you can choose. It's especially interesting for tubes, pipings, and so on, or for vessels to keep the temperature inside with the needed temperature. For example, you want to keep 40, 60 degrees inside. You use a PCM of 40, 60 degrees and make a cover of another insulation around, so you have a very long performance. Also, this you can apply in all the forms. I said before, you can apply it as a panel, you can apply it as a loose material or as a powder or in a paste form as well. What does happen? PCM you have in a dry form. It's a dry liquid. It's permanent binding. It absorbs itself. It's a little bit like a sponge, the material. Just put it on and it's inside, it's bound. And you can use it for flexible shapes. Here again, self-loading, loading within seconds. It depends a little bit on the liquidity, how fast it goes. On the left side, on top, you can see our flakes loaded with the PCM. It's pourable, it doesn't give agglomerates, and it has a very high performance, extraordinary capacity. We load usually 3 to 4 times of its own weight into the capsule, but also up to 6 times is possible. It depends a little bit on the expansion of the PCM inside the material, that it doesn't come out. And it's a permanent integration because the capillary forces are very high. The fields of applications here: maintenance of temperatures in pipelines, shaped parts, and loose fill in refrigeration, coolers, and thermal boxes. Thank you very much for listening. You can now if you have some questions, ask me, and otherwise there's a possibility to come to us. We have a small booth in Hall 4, 508K. Any question?